Okay. May I also request Director Sabrina Domingo to read the citations.
It is an honor to present to you the winners of the 2025 NAST Environmental Science Award. The National Academy of Science and Technology Philippines awards the special citations to the NAST Environmental Science Award to Pierre Angel Vital, PhD in Biology from the Natural Science Research Institute at the University of the Philippines, Diliman. In recognition of her research achievements and continued efforts to promote and strengthen the discipline of environmental microbiology, particularly her research entitled Characterization of Isolated UVC Irradiated Mutants of Microalgal Flora vulgaris for future biofuel application. She pioneered the investigation of underutilized and neglected resources in the country, which highlighted the importance of environmental protection and biodiversity conservation. Pwede po yung pamilya sumama. She also leads advocacy and information dissemination on handling microalgae through workshops, which directly benefit the environmental and the general community. She fostered holistic participation in the conservation of these sites to dialogue and workshops with the local community and government. Her work undercovers the importance of scientific and local knowledge for successful conservation of Philippine biodiversity. Given this 5th day of May 2025 in Quezon City, Philippines, signed by Academician Rodora Sasa, Chair, Board of Judges, and Academician Jaime Montoya, President of NAST. Congratulations po. Next. Ay, pasensya po kasi parang yung aking binasa eh. Okay. The next citation, special citation is given to Dr. Cecilia B. Moran, Direm Natural Biology from the University of Santo Tomas, for its significant research entitled Surveys, Assessment, and Environmental Monitoring of Key Economic Activities and Livelihood Associated in the Mangroves or Sakalam of Del Carmen, Siargao Island, which paved the way for the recognition of the Del Carmen Mangrove Forest Reserve, Del Carmen, Siargao, as a Ramsar site of the Philippines, a wetland of national and international importance. Pwede pong kunahin ito po ang kanyang ang asawa niyo po. Dr. Moran's study of these mangrove sites thoroughly assessed their hidden biodiversity and made educational promotion to install the importance of the mangrove environment in the community. Given this 5th day of May 2025 in Quezon City, Philippines, signed by Academician Rodora Asasa, Chair, Board of Judges, and Academician Jaime Montoya, President of NAST. Congratulations, Dr. Moran. Now, for the 2025 winner of the NAST Environmental Science Award, the National Academy of Science and Technology Philippines awards the 2025 NAST Environmental Science Award to Dr. Laura T. David, PhD, Physical Oceanography of the Marine Science Institute, University of the Philippines, Diliman. In recognition of her pioneering research entitled Climate Change Impacts on Coastal Communities, which delved into the potential climate change ramifications on Philippine coastal habitats with subsequent effects on food security. The assessment of coastal inundation, vulnerability through storm surge, and sea level rise simulation has shown coastal municipalities within vulnerable provinces that require urgent attention. Yung family po ni Ma'am, pwede po si Mama. The study also looks into leveraging the capacity of mangrove and seagrass ecosystems for carbon sequestration in mitigating climate change impacts in coastal areas. Dr. David's earnest dedication to what she calls people-relevant ocean science ensures the sustainability of ocean resource monitoring and management through collaborations between higher education institutions, local government units, national agencies, and international partners. Cognizant of the social dimension of her work, she always seeks opportunities to develop science communication initiatives to better connect with various types of stakeholders to protect both coastal environments and coastal communities. Given this 5th day of May 2025 in Quezon City, Philippines, signed by Academician Rodola Asansa Chair, Board of Judges, and Academician Montoya, NAST President. Dr. David will receive a plaque of recognition and cash prize of 150,000 pesos from NAST. Our winner is also entitled to the Law Secretary's grant worth 2 million pesos, which she will receive upon submission and approval of a research proposal. Congratulations.
Again, congratulations to all our winners. Before we proceed to the paper presentation, I would like to remind our online audience that you may key in your questions at the Q&A slot below your screen. Facebook users may also ask through the comment section, and your questions will be answered by our speaker during the open forum. Also, don't forget to use the hashtag Filipinas, hashtag NESA, and hashtag NAST Awards in your social media accounts. So our speaker is Dr. Laura David. He's a professor of oceanography and ocean remote sensing at the Marine Science Institute of the University of the Philippines, Diliman. She co-developed ARAS and Fish Eye, which facilitates rapid assessment of coral cover and fish biodiversity. Fish Eye has patents in USA, Indonesia, Mexico, Brazil, and the Philippines. Her passion in science communication led to the development of a citizen science manual for coastal resource and resilience at Survive and Thrive, a commercially available game relating ocean health, climate change, and human resilience. She is an Academy member of Future Earth Coasts, and she obtained her PhD in Physical Oceanography from the University of South Carolina and BS Chemistry from UP Diliman. Let us now hear from our speaker as she presents her winning research entry titled Climate Change Impacts on Coastal Community. Let us all welcome our 2025 winner of NAST Environmental Science Award, Dr. Laura David.
Thank you for this opportunity to share the work that we've been doing at the Marine Science Institute. So, Filipinos primarily rely on the ocean for a lot of things, including our food and a lot of our livelihood. We eat about 40 kilograms of fish a year per person, whereas the rest of the world eats at an average of 16 kilos a year. So almost more than times two. Aside from that, we actually have about 1.6 million people associated with the fishing industry, and yet they remain the poorest of the poor. And fishing contributes about 2% of our GDP. Okay. If you take a look at the picture and look at the population of the Philippines, 56% or nearly 60% also live near the coast. And that will become relevant as I talked about later. At the same time, the Philippines is located in the Ring of Fire, so we do have earthquakes and volcanic eruptions. And as everybody knows, about 20 typhoons enter the Philippine area of responsibility every year. Historically, we've also had a lot of storm surges. And if you take a look at Leyte in particular, actually it's been hit 3 times before the last Yolanda. So we rank one of the highest countries in the world to experience overall natural hazards. On top of this, we now have climate change. So on the left is a map of all the typhoons that have caused during this particular decade, so in the 60s, 1980s, and 2000. As you can see, if you count the lines, they haven't changed. It's about 20 a year. But the colors have changed, and the color is actually associated with the strength. So before, they were mostly signal number 1 and 2, and then it became 1, 2, and 3, and now we experience signal number 5. Okay? So that is your climate change. It's an increasing strength of all the typhoons. But that's not all when we talk about the ocean environment. The ocean environment, not only do you have to deal with storms, you have to deal with heating, you have to deal with rainfall or lack thereof, and then you have to deal with sea level rise. So we wanted to do a study on that to see how all of these climate change impacts, in particular extreme average temperatures, extreme rainfall, intense storms, and sea level rise are actually going to affect your coastal habitats and have cascading effect on your fisheries, your livelihood, and also the security of all the coastal communities. This summarizes what happens with climate change. If you have warmer waters, naturally you will have bleaching, coral bleaching. So a lot of people are now familiar with that. About 2 decades ago, I was in a coastal area with my students, and I always tell them to try to explain what we're doing to the local communities, especially the fishermen. And we were trying to describe what coral bleaching was. We said, kasi mahalang pag uminit, yung mga bahura, nahihirapan sila, so yung kanilang kaibigan na so sa tiling, nakatira sa kanilang algae, umaalis at nagpapalisik ang kulay. Sagot ni Manong sa akin, coral bleaching. Diba? So mas alam na nila yung concept even 2 decades ago. So that's great because that means they have observed what we actually also observed. Na nagpapalit nga yung behavior ng corals pag nag-iba yung dagat. At the same time, with your higher intensity storms, you have higher wave action. You also have higher rainfall, and that cascades into 2 things. Higher energy near the coast, and you have high sedimentation from what coming from your watershed. So seagrass will be the most affected because of this. They're plants, after all, and they're living near water. So if the water becomes turbid, even for a few days, you'll have reduction of the productivity because of photosynthesis. But if the sedimentation actually lasts longer, they might actually die off. And then, sea level rise will affect your mangroves the most. Corals and seagrass are already underwater, so they'll be fine. But mangroves, they actually just tolerate salt water. They don't necessarily like to be inside salt water all the time. They just dominate the coastal areas because other terrestrial plants cannot tolerate salt, right? But if the mangrove themselves are always underwater, their root crops are always underwater, they won't be able to breathe, especially the youngs. No? The seedlings need at least 46 hours of sunlight and above water for them to keep growing. So with sea level rise, they will die. And then finally, with heating, you also have decreased oxygen in the water, so you experience fish kill. And a cousin of heating with carbon dioxide is ocean acidification. And there are multiple studies now that show that there are several flora and fauna that will thrive with heating and acidification, like jellyfish, but there will be a lot that will actually suffer, especially those that have shells. So we then had to look at what happens in the Philippines. So in order to get data that is long enough, we had to resort to remote sensing. So because we don't have actual observations of areas except maybe for Manila Bay and Puerto Galera that last more than 50 years. So we took remote sensing, remotely sense available data of temperature, sea surface height, and precipitation. We gridded them both in space and time so that we can compare them. And then we let the data speak for itself. We allowed them to group themselves so that those that have commonly experienced the same thing in the last 25 years, so this is just a 25-year data, then they will group themselves together. And it shows that the Philippines actually divides into 11 types of groups. So some, especially that in the northeast, and the rest of the Pacific seaboard, show that they will be suffering different things, including extreme heating events, increased ocean temperature, extreme rainfall events, disturbed water budget, and sea level rise. I'd like to explain the disturbed water budget. That means it's supposed to be summer and no rain already, but it keeps raining, or it's supposed to be rainy already, but there's no rain. Okay, so all this have changed in some areas, but in some areas, they have only been suffering sea level rise, none of the rest. But it's none that are drastic enough to show up in the data. Okay, so we did this, so basically it shows that the Philippines is heterogeneous. So different approaches has to be done in different areas because we're not going to experience the same thing. So we overlaid this on, again, a remotely sensed product of corals and mangroves. Notice that there's no seagrass initially in the area because it's very hard to do remote sensing in seagrass areas. But what we did is if there's coral and mangrove in the same area, most likely there's also seagrass in those areas. And if we see green that's near the coast, we factor in that that's probably a seagrass. Okay. So we overlaid that, and as you can see, in areas where there's coral and extreme heating events, for example, in the northeast and then the northwest, that means corals will be the most likely habitat to suffer, whereas those that are in the south, which only experiences sea level rise, mangroves will be the one that will most likely suffer. So we did that analysis, and we overlaid that on fisher density. High fishing density means there's already a lot of pressure in the area. So if you add on climate change then that's an additional pressure for that area. So fishing density, add on to what is going to happen, what habitat will be affected by a specific climate hazard. We ended up analyzing that there will be places where only the mangroves will be the problem, will experience a problem. There are areas where coral, mangrove, and even offshore areas will experience a problem because of increasing temperature. And we went all the way down to provinces, right? So as you can see, warm will be the most areas that will suffer the most. And then, but that doesn't spare the rest of the Philippines. Bulacan and Pampanga, for example, will suffer sea level rise and unusual rainfall events. So both the seagrass and the mangrove will suffer. And then some areas it will be everything. So coral, seagrass, mangroves, like Batangas, Quezon, and Cavite, where the iron passage is. So, aside from that, we took a look at sea level rise. And as you can see from the global map, the rest of the Philippines and Japan is actually suffering 5 times that of the rest of the world. So the average of the globe is 3.6 centimeters per decade. We're suffering at 10 to 15 centimeters per decade. So that means that we will experience sea level rise faster than the rest of the world. That's Papua New Guinea as in Japan. So we took a look at that, and there was a study that came out in 2015 by Valdes. Sir, this is from Leeds. And they made use of previous storm surges as well as bathymetry and topography of the area, and predicted the maximum storm surge that will happen per province. And as you can see, they placed number 1 is Samar and Leyte. So talagang sila yung pinaka-susceptible. And then they ranked the rest, the top 30. So we placed both of these together because we then showed that with the possible inundation, the most likely that will be affected are the number of fisher populations that have density. So if there are a lot of fishers in a certain area, they will most likely be the ones affected. Because usually fishers don't live higher, much far from the seashore. The fishing communities will tend to stay near the seashore. Actually, in Tacloban, after Yolanda, who went on the ground and asked them why, if it's possible for them to move further out, and they tried, but being even 150 meters away from the shore is already taxing for them, because they're leaving their number 1 investment, which is their vacas, right? So they can't stay away from the vacas. So they will always be at risk. So we did that, and we went all the way to not just the province, but municipalities. We were able to identify municipalities where we have to give them extra attention because they will most likely suffer from coastal inundation. So again, BARM shows up quite high. Cotabato City, the entire municipality of Cotabato City is actually going to be inundated. And with time, the sea level is actually going to affect the extent of the impact of storm surges. Because if the storm surge now would reach just like the 2010, will just reach this house, because of sea level rise, it will eventually reach farther inshore, affecting more and more of the population. And 64 million of us live near the coast. So you can look at it 2 ways. One, that's a big problem. But if we do the right thing, we will be saving 64 million people. And our small islands, so we have 7,641 islands. If you take a look at the Philippine map, only 11 of them are big. Right? Masbate, Romblon, Marinduque are the smallest of the big ones. Most areas are actually small. So 7,650 islands are small, and they are populated. You have fishing, it starts out as a fishing village, and they just stay there, and the population grows. So these people will be inundated. So again, we went all the way down to municipalities and showed that with sea level rise and possible flooding with storms, these are the ones that will be affected most. So what do we do? So for food, we should implement multi-habitat FTA. Studies have shown that if mangrove, seagrass, and coral are around, you actually have higher biodiversity, higher biomass, higher density of fish. So if we protect them now, as the climate is changing, they will be more resilient to that climate change. It's just like if your family has diabetes and you don't change your lifestyle, you will most likely be one of the statistics. But if you change your lifestyle, there's a probability that you will get your diabetes way later in life or not at all, right? So if we make sure that the habitats are healthy, we protect them. When the climate change is happening, they will have better probability of surviving that and thriving in that new environment. Number three first, develop appropriate supplemental livelihood. We already identified areas where the fishers will most likely use what type of fishing. It's mangrove related, seagrass related, or coral related. Note on that, we have statistics on those that are coral related, but we don't actually have enough data for seagrass and mangrove related fisheries. So that should be studied as well. And then three, the second one is strict implementation of the 15-kilometer municipal water for fisheries. Why? Because there is such a thing as an edge effect. If you narrow down the municipal water from 15 to 10, you will most likely affect those that are even inland, like all the way to 5 kilometers from shore. But if you keep it at 15, you have that 5-kilometer buffer, so 10 kilometers offshore is protected. And develop a lot of tools so that the citizens themselves can actually observe what is happening in the ground. Second, to protect those communities, make sure that all your essentials, like your schools, your hospitals, your areas where you evacuate people to, those should be higher than the projected sea level rise, storm surge, and if historically it's been hit by a tsunami, also by the tsunami line, right? Because otherwise, the very essential infrastructure that you need when disaster happens will be underwater, just like what happened in Yolanda. So you make sure that they are in the lowest zone. So if you take a look at the study of Valdes, the highest there is 6.47. So 7 meters above current sea level height would be the safe zone. You can still make use of the zone that's lower than that for mixed use, but make sure there are plans on how to evacuate these areas and make sure the architecture is such that it can withstand the strength of your storm surge. Of course, again, the fishers will always be in the danger zone because of their livelihood. I actually talked to fishery families in Tacloban, and my solution was that they only make use of that as a workplace, and that they live in the medium risk zone because unfortunately maraming nawalan ng tatay during the time of Yolanda. Because the men stayed in the house to protect the TV, the refrigerator, the few possessions that they actually have. And the mom and the kids were able to be evacuated from the area. So they lost a lot of the dads. So that really broke my heart. And so I said, no, just make use of that. There's a house, but only the dad lives there because of the livelihood. The kids live and the moms live away from there so that when there is danger coming, the dads can just leave, right? Because none of the big item things that they pressure would be with them. The moms reacted, say, if you let him have a house there will be a second family there. It's like, okay. So what's the solution? So we had a dialogue with them, and they proposed something like a kampong in the olden days, where there will be like 10 men living together in a long house, and they take turns going home. They take turns taking care of the bangkas, and the wives and the kids will stay in the safer zone. That they can enjoy. So that means that this shows the scientists don't have all the solution. We have to hear out of it. Okay. And then finally, how do we fund all of this? We only have limited resources. We have a lot of issues that we need to look at nationally. But there is actually a possible source of funding for all of this. It's been shown that oceanic and estuarine mangroves actually sequester carbon dioxide twice to 3 times that of your rainforest. So we just have to protect those and plant more of those. Seagrass as well is comparable almost to what the rainforest sequester. So we also need to protect those, right? So we went around the Philippines, did about 17 sites to actually measure. And the first observation is our measurement in the Philippines is far higher than the global average. So the global average, for example, for mangrove is about 380 megagrams of carbon per hectare. We are talking at 510 to 780. Okay, so the potential is quite high. They're used, so if you just calculate the carbon dioxide, so you multiply that by 3.67 for those who remember your high school chemistry. So you end up with about 2,000 grams of carbon dioxide per hectare of mangrove forest. We used to have 3 million hectares of mangrove. We now have 0.3 because of multiple reasons. Fish ponds, reclamation, just use of the area. So if we just bring back what we lost, why do we do that? Because that means in those areas they used to survive. That's a great area for them to thrive again. So if we just bring back 2.7 million hectares of mangrove. So you multiply the 1872 or 2863 by 2.7 million hectares. You're talking about 5,000 to 7,000 million metric tons of carbon dioxide. You can offset that. You can offset the annual emission of EU plus USA with that carbon. So if they cannot carbon zero by reducing their use, they can carbon zero by giving us the money so that we plant the mangrove and protect the seagrass to offset what they're using. Right? So there is possible funding. So basically, sorry, that's the same calculation. So the key points are, Filipinos rely heavily on food, fish for protein resource. So we're vulnerable because of that. Fishers at the highest risk because they also not just use the place for food and livelihood, but also live in those low-lying areas. Climate change impacts are site-specific, so therefore the solution has to be site-specific. Adaptation is necessary not just for our survival, but according to Secretary, also to thrive in the environment. So policy inputs at the local level to include all coastal habitats in the marine protected area. Right now, we only say coral reefs. Sometimes mangrove, never seagrass except one area in Philippines. Right? So we have to protect all of them. Implement a no-build buffer zone landward of mangrove forest. Because naturally, as the sea level rises, the next generation of mangrove will just move away from the ocean. But if there's already a road there, a promenade, or a mall, then they won't be able to naturally adapt. Provide alternative and appropriate livelihood for fisher families so that they're not fully reliant on fisheries. Plan for future development of essential structure like hospitals and schools and evacuation areas na ilagay na siya sa low-risk zone. And assist in adaptation of current coastal dwellers either by slowly relocating them. So we do have the IPCC scenario of how much the sea level will increase per decade. So we can just start with those that are very near the coast and slowly relocate them up. It doesn't have to be all done, now. Not all 69 million have to be moved, but a few of them have to be started to be moved. At the national level, revisit the law of easement. From the coast right now, the law is 3 meters, 10 meters, and 40 meters away from the coast. There's no scientific basis for that. That's an old rule during the Spanish time that was just incorporated in our laws. More for controlling the population. Instead, use the elevation. So if your particular area will be elevated by 3 meters, storm surge should at least move 3 meters above that sea level rise. But if you have to do a law, 7 meters would be the law because it has to incorporate everybody. And institute appropriate actions that will allow us to find all of this necessary adaptation. Yun lang po, ang karagatan ay buhay, pero ang karagatan ay also buhay na. Salamat po.
Thank you very much, Dr. David, for your presentation. Okay. Now, so we now proceed with the open forum for the question and answer portion.